In 1864, a massive explosion ripped through a laboratory in Stockholm, instantly killing 5 people. One of the victims was the younger brother of a 31-year-old chemist named Alfred Nobel. Most people would have walked away from the volatile liquid that caused the destruction. Instead, Nobel decided to tame it. I am going to show you how a man widely remembered for one of the world's most prestigious peace prizes actually built his empire by engineering some of the most destructive compounds of his time. Born in Stockholm in 1833, Alfred Nobel grew up around the business of destruction. His father, Emanuel, was an engineer who manufactured naval mines. But the real turning point in Alfred's life happened in Paris in 1850. While studying chemistry, he met an Italian chemist named Ascanio Sobrero. 3 years earlier, Sobrero had synthesized a highly unstable liquid by adding drops of glycerin to a cooled mixture of nitric and sulfuric acids. He called it pyroglycerin. Today, we know it as nitroglycerin.
Nitroglycerin was an incredibly powerful secondary explosive. It contained its own oxidizing agent right within its chemical structure, allowing for a rapid, self-sustaining decomposition into hot, expanding gases. But as a liquid, it was notoriously unpredictable. It could detonate from a minor temperature shift, spontaneous chemical decomposition, or just a bumpy carriage ride. It offered immense power for industrial mining and civil engineering, but it was simply too deadly to transport or use reliably. When Nobel's family armament business went bankrupt in 1859, he and his father returned to Sweden and set up a laboratory to experiment with this volatile oil. They wanted to figure out how to harness its raw power safely. But nitroglycerin does not forgive mistakes. And in 1864, that catastrophic explosion at their Hellenborg factory took the life of Nobel's younger brother, Emil. Nobel did not quit. He doubled down. He realized that to control nitroglycerin, he had to completely rethink how explosives were triggered.
Prior to Nobel's work, explosives like black powder were initiated with a simple fuse. They relied on the transfer of thermal energy, heat, to trigger rapid combustion. But true high explosives, like pure liquid nitroglycerin, do not respond reliably to heat. They require a sudden, massive kinetic shock to break their molecular bonds simultaneously. Between 1863 and 1864, Nobel solved this by inventing the blasting cap. This was a small copper percussion cap filled with a primary explosive called mercury-2 fulminate. Mercury fulminate has a nearly linear molecular structure, making it highly sensitive to minimal stimuli. When initiated by a standard fuse, it does not just burn, it detonates with extreme brisons, propagating a supersonic shock wave at a velocity of roughly 4,250 meters per second. This intense kinetic shock wave, rather than heat, strikes the secondary explosive and triggers its simultaneous molecular breakdown. With this single invention, Nobel birthed the modern explosive train concept, using a highly sensitive primary explosive to safely trigger a stable, powerful secondary explosive. The blasting cap solved the initiation problem. But liquid nitroglycerin was still far too sensitive for everyday transport and construction. Nobel needed to physically stabilize the liquid itself. He tested absorbing the oil into brick dust, coal dust, and waste wood. Nothing worked perfectly. Then, in 1867, he discovered kieselguhr, diatomaceous earth. This is a fine powder made of fossilized algae. Kieselguhr is exceptionally porous and can absorb up to 3 times its own weight in liquid nitroglycerin, converting the volatile oil into a thick, putty-like paste. This was a masterclass in material science. The physical stabilization worked on multiple levels. First, by trapping the liquid in microscopic fossilized pores, the nitroglycerin could not form large, contiguous pools that are highly sensitive to shock waves. Second, the inert silica structure of the kieselguhr acted as a microscopic shock absorber. It now required a massive, deliberate shockwave provided exclusively by Nobel's blasting cap to trigger a detonation. And because the kieselguhr was inert, it stabilized the chemical without diminishing its raw explosive yield. Nobel molded this dough-like substance into paper-wrapped rods that easily fit into mining boreholes. He called it dynamite. It completely transformed global civil engineering. Dynamite was revolutionary, but it had a flaw. In damp environments or underwater, water could displace the nitroglycerin from the kieselguhr matrix. The highly unstable liquid would sweat or ooze out of the paste, creating a massive hazard. Nobel found the solution in 1875 entirely by accident. He had cut his finger in the laboratory and applied collodium, a liquid bandage made of nitrocellulose dissolved in ether and alcohol. Later that night, kept awake by the throbbing pain of the cut, he had a realization. The nitrocellulose in the collodium could be the exact compound needed to chemically bind with nitroglycerin. He rushed to test it, dissolving nitrocellulose directly into liquid nitroglycerin. It formed a firm, gelatinous matrix that bound the two explosive compounds together chemically. He called it Gelignite, or blasting gelatin. It was entirely water-resistant, eliminated the sweating hazard, and was significantly more powerful than dynamite because both components were active explosives. Nobel kept iterating. In 1887, he combined equal parts of nitroglycerin and nitrocellulose to invent ballistite, a nearly smokeless propellant. Ballistite replaced black powder in firearms, ensuring that battlefields were not instantly blinded by thick clouds of smoke. But ballistite brought Nobel intense political trouble. He offered the patent to the French government, but they rejected it, so he licensed it to the Italian military instead. In response, the French government and media orchestrated a ferocious smear campaign, baselessly accusing Nobel of espionage and stealing secrets from French laboratories. Facing threats of imprisonment, his laboratory was raided by police. Disgusted by the unfounded accusations, Nobel left France permanently in 1891 and relocated to San Remo, Italy. We remember Nobel for his explosives, but his scientific curiosity was boundless. Over his lifetime, he secured 355 international patents. He conducted deep research into polymer chemistry, filing patents for artificial rubber, synthetic leather, and artificial silk. He even designed rocket engines with timed ignitions. And he also harbored a profound interest in physiology and cardiovascular medicine, establishing a private medical research laboratory in Sèvres, France. And it is here that we find a deeply ironic twist in Nobel's life story. In his later years, Nobel suffered from severe angina pectoris, intense chest pain caused by reduced blood flow to the heart. To treat the condition, his physicians prescribed him a potent vasodilator to relax the smooth muscle of his blood vessels. The drug they prescribed? Nitroglycerin. Nobel was highly amused by the irony. He noted the peculiarity of consuming the exact active ingredient of dynamite, the compound he had spent his entire life industrializing, just to soothe his own failing heart. For pharmaceutical purposes, doctors often referred to the drug as glyceryl trinitrate to avoid alarming patients, but Nobel knew exactly what he was taking. If you know anything about Alfred Nobel's personal life, you have probably heard the famous story of his obituary. The legend goes that in 1888, after the death of his brother Ludwig, a French newspaper mistakenly published Alfred's obituary under the scathing headline, "The Merchant of Death is Dead." According to the myth, Nobel was so horrified by this legacy that he immediately drafted his will to establish the Nobel Prizes. It is a great story. But rigorous archival research reveals it is heavily embellished. Extensive searches of the French National Archives have failed to produce any 1888 newspaper featuring the headline, "The Merchant of Death is Dead." A mistaken obituary was indeed published by the newspaper Le Figaro, but its contents were far less theatrical. It simply read, "A man who can only with the utmost difficulty be considered a benefactor of mankind has died yesterday at Cannes. It is Mr. Nobel, inventor of dynamite." The paper retracted the error the following day. The highly dramatic "The Merchant of Death" headline was likely popularized decades later in a 1959 biography. While Nobel probably read the uncharitable Le Figaro blurb, treating it as the sole panicked catalyst for his philanthropy ignores his actual life. He had a long-standing documented interest in the sciences, medicine, and pacifism. He maintained a close correspondence with prominent peace advocates, holding a paradoxical belief that creating a weapon of ultimate destruction would act as a deterrent to war.
When Nobel signed his final will in 1895, a year before his death from a stroke, he dedicated 94% of his vast fortune to establish the Nobel Prizes. It was a calculated decision from a methodical engineer, not a sudden panic over a sensationalized headline. Alfred Nobel was a man of profound contradictions. He was a chemist who tamed an uncontrollable liquid, an industrialist whose inventions shattered mountains, and a philanthropist who funded the highest achievements in human progress. He built an empire on destruction, yet left a legacy defined by peace and scientific discovery. It makes you wonder, if you engineered a technology that completely changed the world, but you knew it could be used for immense harm, how would you choose to write your final chapter? Let me know your thoughts down in the comments. If you enjoyed this deep dive, be the primary explosive to my channel's explosive train. Hit that like button and subscribe to LynxSifts Science and Technology for more verifiable facts and incredible stories. I will see you in the next one.